Hey, Scott here, and in the last video, the Crash Course 1, we talked about the refrigeration cycle. I requested that you watch Mike Ehrman and his videos on the refrigeration cycle, and also went through what's going on here. If you can't draw this out yet with a blank sheet of paper and a pencil, if you can't draw this out and do it from memory, then stop, go back, watch those videos, and be able to do that. I'm going to do something a little unorthodox right now. I'm going to jump forward to electrical. And in Where Do I Begin video, I talked a little bit about the electrical circuit too. L1 to switch, switch to load, load back to L2. It's a very simple drawing. It shows you a generator generating electricity, a real basic switch, knife switch. A light bulb represents the resistance or the load. What's happening is the electricity is going through a fine wire, a very fine filament, and when the electrons hit that, they are forced to change state because the electrons can't all flow through that tiny little wire. And energy cannot be created nor destroyed, but it can change state. And with this light bulb, it changes state by becoming both hot and emitting light, and that is the energy of those electrons changing state. It goes back to L2. That's the basics of an electrical circuit. Electricity is essentially electron flow. It's the electrons jumping from atom to atom. Let me show you another diagram. Here's that generator again. Here's L1. You could call this L1, but I'm calling this L1. L1 to switch. There's my switch. Switch to load. This is the resistance. This resistance could be a light bulb or it could be a motor. And on the other side of that, if I went straight back to there, L2, that would be a simple, very simple electric circuit. But in this drawing, we are daisy chaining another resistant. So we got resistance 1, or load 1, load 2, load 3, and they're daisy chained together. And here it comes out, finishes all the loads, and heads back to L2. So this is the L2 line. This is called a series circuit because everything is strung together in series, just like Christmas lights. So if you break this line right here or anywhere, if a bulb burns out, they all stop. They all burn out. L1 switch, switch to load, load back to L2. Series circuit. This same circuit can be drawn much more simply as a rectangle. This little symbol here represents the power source, and that's essentially a sine wave. And that's your power source, and this is your switch. And going this way, this little squiggly line represents resistance or a load. Where you find resistance, you find the work being done. And they're all strung together in a row, which means they are a series circuit. Let's find a parallel circuit. This represents parallel. And in a parallel circuit, L1 to switch, switch to load. You've got L1 on one side of the bulb. This could be a light bulb, let's say it is. And then you go L1 to the other light bulb, and then you go L1 to the third light bulb. These could be motors, but I'm calling them light bulbs. And then you take L2, you put L2 on that side, L2 on that side, L2 on that side, and these are run in parallel. This is an electric circuit drawn in parallel. This is the same circuit drawn more simply with your power source, your switch, and it's kind of a ladder diagram where you've got 3 loads drawn parallel. Take a quick look there. There's a series circuit. There's parallel. Many technicians make their beginning mistakes when they wire up a system in series rather than parallel and do not understand why it doesn't work. The properties of the electric circuit You'll notice your power source, your switch. When you're checking on the same line, this is line 1 here, when you're checking on the same line, you are checking amperage. When you are checking across the load, you are measuring voltage. Voltage is a measurement of the electromotive force or the electrical pressure, and in order to read that pressure, you need to have resistance between your two leads, or you need to have the line open. So if you measure across an open switch, you can measure the voltage, because that's a measure of the electrical pressure. If you measure across a working load, you can measure the voltage. The amperage has to be measured in series while the current is flowing, while the electrons are flowing. And I don't know if I want to get into the differences in voltage or amperage. In a parallel circuit, your voltage stays the same on each load, on each resistance. Your voltage is the same, but your amperage will be shared among them. The series circuit is the opposite. Your amperage will stay the same, but your voltage is shared. In the series circuit, your voltage will be shared. And we can see the formula for that in air and pi. And I guess I'll move forward to this. This is a nice little representation of how to find your formulas. So air, EIR, E for electromotive force or EMF, I for intensity or current or amperage, this is your current, and R for resistance, this is your load, this is the work. EIR. Now if you cover up with your thumb the E, then it'd be I times R to find the voltage. So E, EMF, or V, voltage, that's what this is. So E equals I times R, amps times the resistance. To find the current, cover up the I, and then I would equal E divided by R, or your volts divided by your resistance, and your resistance is measured in ohms. I know that's a lot to take in all at once. Resistance is measured in ohms. I equals E over R, volts over resistance. Resistance is found by E over I. That's volts over amps. And there's your basic formula for that. And no, not this one. That same technique works for pi, power, amps, and volts. Use the same thumb technique. Alright, my phone's ringing, so I'm going to have to go to the next lesson.